Hello, this is Maria Talara. This is microbiology experiment, antibiotic sensitivity, Kirby-Bayer diffusion test. In this experiment, we will describe antibiotics and antimicrobial agents. We will outline how penicillin, novobiacin, and gentamicin work. We will summarize the process of a Kirby-Bayer diffusion test and then compare Staphylococcus epidermidis sensitivity to the three antibiotics. During this experiment, I learned the difference between bacteriostat testic. Let me see so I can pronounce that better. The bactericidal versus bacteriostatic. So a bacteriostatic antibiotic causes inhibition of growth rather than a cell death. Meanwhile, bactericidal means it leads to the cell death. Antibiotics are natural substances produced by microbes that destroy or slow the growth of bacteria. Antimicrobial agents are synthetic substances developed in the laboratory that mimic the effects of antibiotics. And for this experiment, we use three antibiotics. One is the penicillin, which is very very known antibiotic. It is a bactericidal, meaning it kills the bacteria. It's a narrow spectrum drug that targets primarily gram-positive bacteria. The penicillin disrupts the formation of bacterial cell walls by inhibiting the formation of the peptidoglycan crosslinks, resulting in the death of the cell. The second antibiotic we used is novobiacin, which is a bacteriostatic, meaning it only inhibits the growth, it doesn't cause the cell death. It's a narrow spectrum antibiotic that targets DNA gyrase in some gram-positive bacteria. DNA gyrase is an enzyme necessary for the replication of DNA, and without DNA replication, bacterials usually don't grow and divide, so that inhibits the growth of bacteria. The third antibiotic that we're gonna use is gentamicin, which is a narrow spectrum bacteriostatic, which just inhibits the growth of bacteria. It targets aerobic gram-negative bacteria. Gentamicin binds with the bacterial ribosomes, which is a cellular structure responsible for protein synthesis. So I guess it's since it is the energy that provide the cell with the necessary energy or protein, so the bacteria just cease to grow and divide, so inhibits the growth of the bacteria. For this experiment with the Kirby-Bayer diffusion test, which is those little prepared filter paper discs that is infused with the concentration of the particular antibiotic. For this experiment, it is the three antibiotics we just mentioned. We place it on agar containing newly plated bacteria, and we separate the agar plate in three areas where we can put this disc. And as the bacteria grow, they will inhibit in regions where the antibiotic concentration is above what the microorganism can handle, and in areas where the antibiotic concentration is low, will allow the bacterial growth around, and the growth will lead to the creation of a lawn across the plate, creating the zone around each disc. The diameter of this zone of inhibition is measured in millimeters and compared to a chart that links the size of a zone of inhibition to the dosage that is often administered to a patient. The diameter of the zone is dependent on the sensitivity of a microorganism to the particular antibiotic and the physical properties of the antibiotic itself. So let's go ahead and start our our experiment by preparing our supplies. Okay, bye.